solve this question, this is also based on pseudo force in vertical direction. So all the questions till now we are discussing is in vertical direction. So pseudo force in vertical direction. So okay, so what is the question here? Find the reading of the spring balance shown in figure. Find the reading of the spring balance shown in figure. The elevator is going up with acceleration of g by 10. The pulley and the string are light and pulley is smooth. Okay, so we will write the equation. So what will be the equation? So suppose we have pulley and we have an object here and another object here. So if we have tension upward and this, suppose this we write as M1, this is M1, okay, and second one is M2. So if this is M1, this is M2, okay. So this will be M1G downward, then tension upward. Now the whole lift is accelerated up, so pseudo force will act down. So pseudo force will act downward, that is pseudo force, suppose mg by 10. So this is pseudo force. So m1g is downward gravitational force and m1g by 10 is the pseudo force. Okay. Now on second object, tension upward, m2g downward and m2g by 10 is pseudo force. So these are the forces acting. Now if you want to write equation, so how do we write equation? So for writing equation, what we can do is, which one is heavier? The 3 kg is heavier, so 3 kg will try to go down and 1.5 kg will try to go up. So this is going down with acceleration a, this will try to go up with acceleration a. So what we can write for this, the object which is going down, we can write m2g down plus m2g by 10 down equal to not equal to, since it is accelerated with a, we cannot write this down, minus tension equal to m2a. Okay, so this is equation 1. And similarly for second object, if we write for m1, if we write, since this is going down, this will go up. So up means tension upward minus m1g downward minus m1g by 10 downward, that is equal to m1a. So that is equation 2. Okay, so in this way we can write these two equations. So how to solve this? And here you can see that there is something acceleration of the lift, that is g by 10. The g by 10 is a0 here. G by 10 is a0. Okay, that was acceleration of the lift. But we have another acceleration a of the block. This a is acceleration of the blocks in the lift frame. We are taking observation in the lift frame. So this is from lift frame or elevator frame. And the a is acceleration of objects, with respect to lift or with respect to elevator. Okay, now if you add these two equations, tensor will get cancelled. So if you add these two, if you add equation 1 with equation 2, you are going to get 11 g by 10 into m2, and this will be minus 11 g by 10 into m2 equal to m1a plus m2a. Okay, now if you solve it, the a will be equal to 11 g by 10 and m2 minus m1 divided by m1 plus m2. So if you solve it, 11 g by 10, and how much is m1 plus m2? So m1 m2 is 3 and 1.5. So 3 minus 1.5 divided by 3 plus 1.5. So it is how much? It will be 1/3 actually. This whole thing will be 1/3. So 11 by 10 into G, right, 11 by 3, 11 by 3 meter per second square. Okay, so this will be acceleration for the objects. Now, one, or we can write 11 by 3, or you can also write it 11 by 30. For generally, if we have the system is not in accelerated frame, in inertial frame, if we see, if from the ground frame, if we see, the acceleration was how much? It was simply g here, but instead of g, we have g effective here, and where g effective can be given by the acceleration minus the the acceleration part due to pseudo force. So that is how much? Since the lift was going up, this will be minus g by 10. So that is 10 g by 11. So in this way also you can do. We can replace this thing, the thing which we have got 11 g by 10. That is what? That is from where? 11 g by 10 is coming from where? That is coming from g plus g by 10. That is coming from g plus g by 10. This g plus g by 10 can be written directly as g effective, and from g effective value will be what? That will be g minus the pseudo acceleration, we can say, and the acceleration part due to pseudo forces. So this is minus a naught and minus a naught. So what is a naught? A naught is minus g by 10, because g by 10 is in upward direction. So this is what? That is equivalent to the downward pseudo force. Okay, so we can write like this. So upward acceleration means the pseudo force is downward. So that's why we are just adding it with g. Finally, it will be added. So we can also solve the equation. We no need to write the pseudo force explicitly. We can just use the g effective at place of g. It will be added like what we have done here. And after this, what we can do is we can find the tension. So what will be tension? So tension, for tension also, we can write direct equation. How much was the tension? Was it 2 m1 m2 by m1 by m2, m1 plus m2 into g? It was the pseudo for the tension equation, the expression for tension in the string for this kind of system. But here we have to write g effective instead of g. So what we will do is 2 into 1.5 into 3 divided by 1.5 plus 3, and g effective is how much? 10 g by 11. So if you solve it, it will be what? So it is 20 g by 11. So this much is the tension in the string, and if tension in the string is 20 g by 11 here, then tension in the upper, this one, the thing which is which is tied with the string, with the spring balance, the tension here will be 2t. If tension here is t, the tension here will be 2t. Then 2t will be equal to what? 2t will be equal to double of 20 g by 11. So 40 g by 11. So this is the tension we are going to get, the upper string tension, or that will be the reading shown in the spring balance. So this is the reading shown. This is the reading of spring balance. So this is the force. Actually, this is the force. So how much reading it will show? It will show 40 by 11, because the reading shown is shown in terms of mass, not in terms of force. So this is the force acting on the this is the force acting on the spring mass, on the spring balance. But if you convert that force into mass, it will be, the reading will be 40 by 11 kg. The reading in terms of mass. Reading in mass. Reading are shown always in mass. So this will be the reading 40 by 11 kg. So this will be the answer.